Okay, so I am now going to talk about division strategies, and the one that I'm going to begin with is long division, also the standard algorithm for dividing. If you hear any noise in the background, I do have 3 children, and one of them is under 2, so just keep that in mind because my boys are doing a pretty good job of staying quiet, but my daughter is not. Um, anyway, so when we're doing long division, I'm going to go ahead and use a 2-digit divisor and a 4-digit dividend. That is what we are currently working on. Now, not all of the students are ready to try this with a 2-digit divisor. And if to become successful with this, they need to do it with just a 1-digit while they're learning the steps. That would be fine with me. Just know that I'm going to go ahead and show this with the 2 digits. Okay, so there's several ways that students could do this to figure out how many times they'll go into 82. The most efficient way would be for them to use some estimation and just kind of see how close. So like 14 is very close to 15, and if they can see those numbers and they know that that's going to be 15, 30, 45, 60, like they have on a clock, that would get them a little closer, and then they could just add the 15 again, get to 75, and we would realize at that point that we could probably put 14 in 5 times. And so that's what I would typically do. I would use estimation strategies of a number that I knew. Another way that they might do that is maybe, and this is a little farther off on the estimation, maybe they can only skip count by tens right now. And so it would be reasonable to think to themselves that that this 10, my estimated 10, times 8 is 80. But we would know that this number is larger, so it would have to be less than 8 times. And so using that, I would maybe go down and try 14 times 7, or even 14 times 6. Do a little bit of side work to come up with that. Those are definitely methods that I could use to get close to here. Another way is simply to do repeated addition. And I say this because if you do this, we know that this is 1, 2, 3, 4. So you see I can count it off. This method is probably going to be, I'm sorry that I'm not moving with it here. This method is probably going to be what is simplest for the students if they are not at the point where they can use the estimation strategies. So like right now I'm at 70, I can't go another 14. So I would be like 1, 2, 3, 4, 5. And I would know that. Typically with division, they say the strategy is repeated subtraction. And so that would be to do this. But we all know that if we already have a student that is struggling with division, most of the time they have a hard time with the subtraction and regrouping. And so when we say, oh, well, it's simple, just keep subtracting it out until it gets there, our students do not feel that that's simple. And so now we're having them do all this regrouping work over here to solve, and we're like, oh, look, now you've done it once. Yes, that is a method that's there, but to just simply say that we can repeatedly subtract, that is not normally something that students that are already struggling with their numbers feel very comfortable with, which is the reason why I go ahead and say, you know how in multiplication we do repeated addition? I'm going to do the same thing, count up my check marks, and see how many times it would go in. Again, any of those methods would work. So what we came up with is 1, 2, 3, 4, 5. So I'm going to put my 5 over my 2 because I looked at both of these numbers. Now, some students like to put a 0 here to make sure they don't use that space. If that is what they need to visually move over, that is fine. I would like to hope eventually they can take that away. But if that's where they're at right now, don't, encourage them to take that away right now. If they are still dealing with this, just go ahead and let them do that placeholder to move over. So now that I have done that, I have 5. Now, no amount of estimation or anything like that actually goes and solves this right here, 5 times 14 for us. We would need to go back, and like I said, when I use that repeated addition off to the side, it already gave me the answer, which is another reason why I like that. We had the answer right here, which I erased. But if they had already done that method, they would have that. If they did not use that method, then now they would just take 14 times 5. Okay, so our students are going to use whichever strategy works well for them. For me, that is standard algorithm. You may have, your student may want to do this. And this right here is the area model. There is another video that shows this. You see they come up with the same answer. Whichever one works best for their brain, we want to roll with that one. So we know that that's 70. So once we multiply those back by each other, we got 70. And now we have to subtract. In long division, we would subtract here. And right now you see that this number is less than this number. If at any time the number that you bring down in your subtraction is larger than this, then you need to go back and fix something. Because like if this number was, let's say I had put a 4 here, and whenever I went and did this, it was actually 26. Well, I would know that I could put another set of 14 in there and I would move it up to 5. So a good way to check as we are going is just to make sure that this number is smaller, which it is. Now that I know that that number is smaller, I'm going to bring down my next digit. Okay? While I'm teaching them, I use arrows. Again, if that step helps, great. If they don't want to put an arrow and they can successfully move over the correct number, then the arrow is not needed. Okay, so now I have 127. Again, if I was doing that repeated addition from before, I could just carry that on and I can just do the work once. Okay, but repeated addition is not necessarily the way that we're hoping that they'll be able to do it. We're hoping that they'll be able to go ahead and do this multiplication on the side. But if they still need the repeated addition, that's fine. So you see that when I did it by 5, it was 70. And I know that if I did it by 10, it would be 140. So we're going to look with this 127, again, using my estimation. I'm sitting here and I'm going to think of what's reasonable. And that would be a number between 5 and 10. Well, the number that comes to mind for me is 7 is between 5 and 10. I'm going to try that first. 14 times 7. Again, in whichever method they can use. Now, when I did 14 times 7, I got a number right here of 98. Well, I can still put 14 in there several more times. So I know that that is too low. And in fact, it's much lower. So I'm not going to go over just 1 now. I'm going to try it by 9. Okay? And as I do this, I am going to do this problem, but I'm going to also show you a little trick that I taught them with 9s so that you are aware of it. It's called the 9s trick. They also know how to do it on their fingers. And if you guys are interested in that method, I'll be more than happy to show you that strategy in a separate video. But since we're working with this 9 here, I'm going to show you the 9s trick that you write down. And it is simply 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then start and write backwards. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Guys, if at any time you cannot see what I'm writing, I'm sorry. I'm trying to do this while videoing myself. So, I'm not necessarily always doing a very good job of that. Anyway, in this 9 strip trick, I just did all the factors for 9 without actually doing any multiplication. I just wrote my numbers 0 through 9 and then 9 to 0. As you see here, I have 4 times 9, so I'm going to go 1, 2, 3, 4, and I'm going to get 36. I'm going to put my 6, carry my 3. 1 times 9 is 9, plus 3 is 12, and that gets me 126. This number is very close to this number, so I'm going to go ahead and work with that. So I am going to put 9 up here, and I know that equals 126. 9 times 14 is 126. And I am back to where I'm going to do some subtraction. So I'm going to erase all this just so that we have some room on this board. When I subtract, I get 1. And now I'm ready to drop down my next number. So I am going to drop that down, and I get 11. Now, at this point, 14 cannot go into 11. That just doesn't make sense. If I only had 11 apples, I can't give someone 14 apples. And this is what I tell the kids. It's not possible. It goes in 0 times. That 0 is important because it is the difference between 59 and 590. So while this 0 was not necessary, this one is. Okay? So when I do that, I would go through and I would say 0 times 14 is 0. But when we have a 0, we know that if we subtract 0, we're going to get the same number. So I don't have them go and do that step unless they need it. Now that I have 11, I don't have any other numbers to bring down. When I don't have any other numbers to bring down, we have 2 options. If we were dealing with decimals, that's a whole nother ball game that I'll have a later video on. But right now we are not. We are doing division with remainders. And so this becomes our remainder. Okay? So 14 goes into 8,271 590 times with 1 group left over that only has 11. This remainder goes up here with a little r. Okay? It's important they add that r because we don't want this just to have 2 1s next to it and become 59,011. We want to say remainder 1. So again, this is 590 is our answer with a remainder of 11. Now, if this was in a word problem and it said how many teams would we, if we had this many students, how many teams of 14 can we make? Well, then our students would have to understand that we would still need 591 teams because this team of 11 still needs to exist somewhere. We can't just, throw a group of students off in the corner and say, hey, we're not doing anything with y'all. So sometimes that confuses them. They'll go and do all this work and the answer really is 591. But in our actual just algorithm, it is 590 remainder 11. So hopefully this explains how we could work this out. Notice that we still did some side work. A lot of times when we are dealing with a 2-digit divisor, that side work is necessary because we can't just easily skip count by that 2-digit divisor. There's only a few that we can do that with that most of the kids know well, such as 10s and 20s and 25s, things like that. But otherwise, it's going to take some additional work. And the students, they get upset. They think that if they have to do something over here, that they're somehow not as intelligent because they had to go and do it on the side. And I try to tell them, I'm a teacher and I still do side work. It's important to know that we're correct, to not try to keep all of these numbers in our head. Okay? So, this strategy is definitely one that would be useful for all students to know, and is our standard algorithm. But there are other methods that can be simpler for them, and I'm going to show those to you in our next video. Thank you.